So the next step after generating a flow accumulation is to define your PowerPoint from which you will delineate your watershed. For this exercise, we have selected this defined location, which is marked by the longitudes and latitudes here. So there are two steps that can be followed. You can use an existing shapefile to delineate your watershed, or you can create your own point file that lie within your desired area that you want to delineate your watershed. So we'll use the first step where we'll create a PowerPoint with these coordinates. So we'll open our Excel. We'll open a blank workbook. And basically we'll just define, we'll give our PowerPoint a name. Then we'll define the latitudes and longitudes. So our point is south of the equator, so our latitude will have a negative sign. Then we'll save our file to our directory that we are using. So it's under Documents, Watershed Delineation, and I will select I will select 97 2003 workbook, so that the 10.5 ArcMap can read. Newer versions will cause problems when reading the file. So I've saved. Come to our ArcMap document. So to create a shapefile from point data, you come to add data, then you look for add XY data, then we'll open the file that we saved. And this is the file in XLS. We'll open the workbook. It was sheet 1. I didn't have another option. And you can define the coordinates here. For this case, I will use the map document coordinate. So the data will be added to your table of contents pane. To create a shapefile, you export this data as a shapefile. There are different options you can have as a database feature, but we want it as a shapefile, so we'll select the shapefile option. Then we'll save our file. This will be added to our map document. So we can remove the After exporting your shapefile, you can zoom into the specific point, and this is where our PowerPoint is, but it's not at the desired location where we want it to be. As you can see, if we delineated this watershed from here, we will get a very small area, but we would desire for it to be at this location or somewhere along this main stream where there is a high flow accumulation, so that we will delineate all the areas upstream of this. So we will start our editor tool, and we'll start editing so that we manually move the point, and we select the PowerPoint that we want to edit. And we'll select that. So we don't want to since we want to manually move it, we will select this tool under the editor toolbar and move our point. You can zoom in further to ensure that your PowerPoint is on the path of a high flow accumulation. After that, we will save our edits and stop editing. That marks the step for creating a PowerPoint. We'll close that window. Another option is to use an existing shapefile, which you just add using the normal routine of adding data onto ArcMap. Add your desired water point. So the next step is we need to snap our PowerPoint. So this is a step where the PowerPoint will be converted into a raster and placed within an area of high flow accumulation. So since we moved our point within this area of high flow accumulation, our PowerPoint will be snapped to this location. If our PowerPoint would have been outside this area, we would specify the search radius to which the tool will search within that radius to place our PowerPoint, snapped PowerPoint, within the point of high flow accumulation. So we'll go to our toolbox, then snap PowerPoint. Our input raster or feature PowerPoint will be our PowerPoint data that we created and edited. The input ID, I will use field ID because it needs a unique identifier. Input flow accumulation raster, I will use flow accumulation that we got from the third step. Then the output will be snap PowerPoint. So the search radius will not specify, since we'll put it as 0 since we already placed our point within area of high flow accumulation. If our PowerPoint would have been outside this, we would have specified the search radius. So we'll click OK and let the tool run. The tool complete successful. As you can see, our PowerPoint has been added to this region of high flow accumulation. As depicted depicted by this blue color that changed from the symbology. After snapping our PowerPoint, we need to delineate our watershed using the PowerPoint that we snapped and a flow direction raster that we generated in the second step. So we'll use the watershed tool in the hydrology toolbox. Then input flow direction raster will be our flow direction that we got from the second step, which is this. The input raster or PowerPoint feature data will use our snapped raster, snap PowerPoint raster, and the value, which is optional. This field is optional. So if you have multiple points that you want to delineate, you will have this field to specify the unique field ID for the different points that you want to delineate. And to give it an appropriate name, just name it as watershed. And you let the tool run. So this will take some time depending on your processing power. So the tool runs, takes some time, then completes, and a raster file will be added to your map. You can turn off all the other layers to view your raster. So this is the watershed file that has been created for the specific PowerPoint. So the subsequent step from this is to convert your raster file into a shapefile. And for this, we'll use the conversion tools. Then we take the option of converting from raster, then raster to polygon, and our input file will be the watershed. The output we will specify as the watershed polygon. Then we'll take this simplify polygon option. Click OK and let the tool run. So this takes a shorter time to complete. Then a shapefile will be added to your map. You can turn these other layers off. So that completes the watershed delineation step. So for hydrological modeling with VIC, one of the key files that is used in routing is called a fraction file. So the last step for this tutorial is to create a gauge fraction file, and our input file will be the raster file that was an output of step 7 of watershed delineation. So the steps that are undertaken to create a watershed or a gauge fraction is a reclassification step, and there are tools in the Spatial Analysis toolbox called the reclass tool, and we'll take this reclassify option in the toolbox. Our input raster will be the watershed, and the location or the zoom level in your map is important for this step to determine how watershed or the gauge fraction will be outlined. So we'll zoom in. I'll close this tool. So we'll zoom in and ensure that we have some margins left at the top and at the bottom and on the sides. So I'll start the reclassify tool once more, and I'll take the input raster as a watershed. The field is value. So we need to reclassify where there is no value to have 1. So this region should have values of 1, and where there is no data, you need to have 0. So the entire region will be exported as 0, while this watershed area will have a value of 1. So I will rename this to 0, and I will rename this as a watershed fraction file. So this is the output raster that we'll get from this tab. And one parameter that we need to specify from this tab is the environment. We need to have the extent output as the entire display of the map. So the processing extent will be same as display. So it will take these edges. So click OK and complete. The tool will run for a couple of minutes, and this is an output that you expect from this tab. So if you turn off all the other layers, the outer region is marked by 0 where there is no value, while the watershed area has a value of 1. So that marks the end of this tutorial. Thank you for your time.